Hey guys, let's have a look at variables. So variables are the basic storage unit of a program. The value stored in a variable can be changed when you are executing the program. So let's just imagine that you define a variable of the type data type integer, all right? So like you define a variable, an integer x, all right? And now this variable x can possess any value that is from minus infinity to positive infinity and a whole number, right? And it can be changed. So if you have a program which takes in the let us say number of 100 rupee notes, all right? So you give the input of number of 100 rupee notes as x. So if you have, let's say, 50 notes, so when you have 50 100 rupee notes, the final amount of money that you have is 5,000 rupees. All right. So let's say you need to create a program like it, which can be used multiple times to find the total amount of money according to the number of notes that are gained by the by the shop. So in such cases, variables can be used, and this is how you can declare a variable where you have the data type and then you have the variable name. And when you have multiple variables, you can use the following thing. Now, one thing to be memorized, to be kept in mind when naming variables is that a variable cannot start with a number. So you can't have 3 underscore x or something. It should always start with an alphabet, which can be upper or lower, or any character, or underscore to be precise. So let's move ahead. So now let's have a look at operators. So operators is the using is what we can be called the usage of variables. There are three types of operators: unary, binary, and ternary. Unary operators involve one variable, binary two, and ternary three variables. Now let's have a look at the unary operators. There are two unary operators: plus plus and minus minus. Now let's head on to VS Code to have a look at this. So let's create a new file called operators .cpp, and let's just copy this code because why not. Alright, now we remove this line and we declare an integer a comma b comma c. Alright, now these are our three variables which are of the data type integer. Now first we are looking at unary operators, right? So let's write a cout statement. Enter variable number one, right? And let's just put a semicolon and let's take the input of a, and now let's do a equals to a plus 1, all right, and then cout a. Yeah, now one thing, if you put when you are using cout statements, all right, so always you can put a end l at the end. What that does is that it ends the line for you, and when you have like multiple cout statements, like if you had a cout uh, hello, what would happen is that a hello would be printed, AHELLO, which is not what we wanted. We wanted a in one line, hello in another line, so you should always use the end l. Or there are alternatives. You can use a backslash n, right? Sorry, forward slash yeah, slash n, and that would also break the line for you. So now let's just save this and let's run it. Okay, so it's asking for enter variable number. Let me just it's asking for enter variable number 1. So let's just say assume any number 7. Now what it printed was 8, which is 7 equals to, so a equals to 7 plus 1. So how a computer works is that it checks the RHS of the equals to sign, and then it assigns that value, it calculates it and then assigns the LHS that value. So over here what happened was, the computer went, all right, integer ABC, all right, I have created storages for A, B and C. Now, okay, I need to print enter variable number 1. I have printed it. Now I need to take input for the variable A. Okay, I have taken the input as 7. Now, oh, what do I see? Variable A is equals to variable A plus 1. What is variable A? Variable A we saw was 7. So 7 plus 1. What is it? 8. 8 equals to A. A equals to 8. Let's print A. Here you have it. You have the value of A as 8. So now here's where unary operators plus plus and minus minus come. So let's just replace this code. Let's just put a plus plus and let's save it. All right. And now when you run that, what happens is, let's enter the number 3. Right. Your answer is 4. What a plus plus did was that a plus plus is nothing but a equals to a plus 1. All right. Same is the thing with minus minus. If you put minus minus over here, right, control S, run it, uh, enter the number 9, 8 is your answer. Same is the thing with a minus minus. Now let's have a look at binary operators. What binary operators do is, there are 5 types: arithmetic, relational, logical, bitwise, assignment. What arithmetic operators do is simple addition. So let's have a look at it. Let's do control C, control V, enter variable number 2. Alright, and let's take our input as B. Let's remove this line and let's use a third variable as well, because why not? Now C equals to A plus B. So what in this case would happen is, the computer goes from line number 6, it sees int ABC. Alright, I have created 3 empty spaces in my memory slot. Okay, let's ask the user to enter the variable 1. Let's take the input for variable 1. Let's ask the user for variable 2. Let's take the input for variable 2. Alright, A equals to whatever the A and B, I have the values for it. Now, okay, what do I see? C equals to A plus B. What is A plus B? A is the value given, B is the another value given. Let's add them. What is A plus B? Is the value. Okay, C equals to this. Let's output it. Now let's run this. Alright. Enter variable number 1, let's say 6. Enter variable 2, 9. Answer is 15. Fair enough? Now the same things can be done for minus, subtraction, multiplication, division and modulus. Let's have a look at modulus. Some of you might not be familiar with it. What modulus does is that, let's imagine you have a case which is 10 divided by 3. Alright. Now what is 10 divided by 3? It's 3 and then 1 divided by 3. Alright, because 3 3s are 9 and then there's 1 remainder. What modulus will do is that it will try to divide the upper number with the first number with the second number, and then whatever remainder is there, it will output that. So let's run this. Now let's save it. Let's run it. Let's take a number like 16, all right, and then let's divide it by let's say 3 or 7, because 7 2s are 14 and then 2 should be the remainder. Yeah, we have got the value of C as 2. So this is how modulus works, if you didn't know. So now we have relational operators next in the line. So relational operators are used to compare the relationship between two different variables. So you have A and B and you want to see if A is less than B or if A is greater than B. You can use this. So like in a if statement, this is usually used in an if statement where you have a condition that if A is greater than B, do this. All right. So in those cases you will use the relation operators. when you want to check if A is equals to B, you use a double equals to, because a single equals to is an assignment operator and it assigns a value to it, and a not does not equal to. So that's the symbol for this is exclamation mark equals to. Logical operators is simple. It's and or and an exclamation mark. So what this does is that if you want to check if A and B both are greater than 7, all right. Let's take an example. A and B are both greater than 7. So to do is you write A and B should be greater than 7. If you want to check whether either of A or B should be greater than 7, you put A or B should be greater than 7, and likewise. Then next you have bitwise operators. So what bitwise operators you might be knowing about, and and gate, or gate, XOR gate, not gates from your previous 11th 12th and all. There you might have learned this. If you haven't learned it, let's learn it on notebook. Let's open a new page, and over here let's have a look at gates. So what a gate does is that this is a gate, all right. You have one input A, you have another input B, and you get a single output C. Now you can give the input as 0 or 1, also here 0 or 1, whatever you want, and then C would give you an answer in terms of 0 or 1, all right. And in the middle you have your gate, which has all the logic in it, which does all the stuff for you. So when we are looking at an AND gate, all right, let's create what we call a truth table. So you have A, you have B, you have C, right? Now when both of them are 0, when both of them are low, you get the answer as 0. When either one of them is low, you get the answer as 0. When, right? Only when both of them are high, that is only when both of them have the value of 1, you will get the answer as 1. This is an AND gate. For an OR gate, it's either one of them should be a high. So 0 0 will give you 0, 0 1 will give you 1, 1 0 will also give you 1, and 1 1 will obviously give you 1. All right, this is an OR gate. Now there's a NOT gate. So NOT gate can be attached next to a AND gate, or next to an OR gate, or next to any other gate, and what it will do is it will simply replace 0 to 1 and 1 to 0. So if you were to have a NAND gate, all right, NAND gate, so what that would be is it would be the inverse of this, which would be 1 1 1 and 0. This would be your NAND gate. Now the last is XOR. So XOR stands for exclusively OR. So it's similar to the OR gate, but over here what happens is that 0 0 would be 0, 0 1 would be 1, 1 0 would also be 1. However, 1 1 will also give you 0. So that is to check if A and B are equal, alright. If both of them have the same value, the answer would be 0. Either both of them have to be different in order to get a high value, alright. So that's gate for you. We'll be looking into left shift and right shift later. It's like binary numbers, and then shifting them by 1 or right, it depends on that. Next we have assignment operators. So it's used to assign values. So let's have a look on VS Code itself. Let's go to VS Code. So over here in the previous example of your binary operators, we had A modulus B, alright. Now if you were to do that A plus equals to B, alright. Now what this would do is, how when we were discussing unary operators, which was unary operators were A plus plus, right? Oops. A plus plus, right? Unary operator. And what it would do was, it would do A equals to A plus 1. This is what a unary operator would do, alright. Now the similar thing over here is, if you write A plus equals to B, what will happen is that it will create A equals to A plus B, right? So let's check it out, and here we'll give the output of A. Let's save this and let's run this. So enter variable 1, let's use 4, enter variable 2, yes, let's use 6, and our answer is 10. What happened was, the computer went, oh okay, I'll create 3 variable spaces, I'll assign the value of 4 to A, 6 to B, alright. And now we see that 4 equal, so now we have A equals to 4 plus B. 4 plus 6. Now 4 plus 6 is 10. So A equals to 10. Alright. And then I'll give that as the output. So it gives the output as 10. So that's your assignment operator finish off. Ternary conditional operators. So that is used in the next topic. We'll be checking the conditions. All right. So a condition if statement. What it does is that if a condition is fulfilled, execute this block of code, and if it isn't fulfilled, execute this block of code. We'll be looking into it further. So here is just condition one. So let's assume that you want to find the difference between two positive numbers. All right, and the difference, because we are finding difference, it cannot be negative, right? So you'll say that if A is greater than B, all right, if A is greater than B, question mark, that's the format. Expression 1. So since A is greater than B, we'll do A minus B, or else we'll do B minus A. That would be our output. So that's your ternary operator satisfied. Thanks for watching, guys. Leave a like if you enjoyed the video. Subscribe for more of such tutorials. Follow me on Twitter at @KevinPKaria. If you have any queries, let me know them down in the comment section or on this email ID, that is ask.kevinpkaria@gmail.com.